everybody's warm. It's kind of cold. Y'all ever get snow down in Columbus? No, just rain and ice. I think it's going to tease us this weekend. A decade ago, we had that snow, what they called it, Snowmageddon. It's just not getting cold. Oh, okay. Well, you're blessed because it's definitely cold where I am. And I'm just a little bit north of you. I know. It's crazy. It is very crazy. Global warming, folks, it's a real thing. It's making the weather go whack and like a little temperature scale just goes back and forth. Like the thermostat is broken. Some days it's warm, other days it's cold. Crazy. All righty. Okay, I'm going to, don't know, I know it's the first day back and first week back, and I don't know how many folks actually going to join us today. We're going to go ahead and get started. So I just want you to, I'm not going to do a deep dive today. We just want you to get a brief overview of where we're headed the next couple of weeks. And actually not the next couple of weeks because this is a short unit. So the next week or so. Alrighty. So again, take a look at the essential questions. So we're going to look at what do we mean by organic materials? Um, what are the types of tools that forensics uses in looking at organic uh, materials for forensic purposes? And there's several different spectrometry, spectrometry. Yeah, that word. It's not coming out this morning. There's a lot of words like that that we'll run into that are just going to twist your tongue all over the place. Spectrophotometry. There we go. Okay. Ah, it's one of those things where you have one word in your head and then you're looking at it and you go, that's not the word you're looking at. So spectrophotometry. So we're going to watch a short video in a little while, just on the different tools that they use in studying um, organic materials when they're doing forensic analysis. Okay. Some you might have heard of and some you might not have. Um, when you took biology, you probably talked about chromography. If you were in a real biology class, you might have even done a lab on chromatography. So we're going to look at what these things are and do a little chemistry class here. Okay. All righty. Got a few more folks in. All right. I do want to say thank you all that majority of you did really well last semester. I do want to ask that you make a great effort to stay on top of all of your assignments so that they're not late. We do have a lot of activities this semester because, like I said, this is kind of like um, the more hands-on part of the class as far as the activities is concerned. So I just want to make sure that you stay on top of your assignments. Okay, and then everybody will be successful as we take this last leg to the end of the semester. All right. And again, good morning to those of you who just joined. All right, so we are in Canvas with those of you, again, for those of you who just joined, we're in Canvas and we're in analytical chemistry. All right. So there are techniques. So again, we want to look at this word organic. And when we're talking about um, chemistry, there are two types of ways that you study. You study organic materials or you study inorganic materials. When we're talking about living things, we're talking about compounds that exist in organic materials. And since our forensics is usually just looking at what happened to a living thing, we are more focused on organic chemistry than we are inorganic. However, we can't leave out the inorganic because in the inorganic materials make up everything. So again, you're going to kind of a brief chemistry review or even science review, where you started off looking at science as there are three states of matter: solid, liquid, and gas, and it depends on temperature as to what state of matter that they're in. And so when we look at, and here we have in this paragraph right here, if we are analyzing evidence, it's important to know what state of matter the remains are showing. We need to understand the behavior of materials, what they will do and what they won't do. And again, knowing what temperature is involved will also dictate whether you're seeing a solid, a liquid, or a gas. Okay? So just take a few minutes to read that paragraph and do the um, review activity. And while you're doing that, I'm going to stop sharing and do attendance now that we have most everybody here. And I will come back with you. So everybody should be in Canvas and a lot of analytical techniques, which is the page after the overview. So read that paragraph and then do the um, interactive activity while I do attendance. Okay, so when I switch to GoGuardian, I want to see everybody doing that. We don't want to have like last semester, some of y'all were logging in and just logging in. Like I have one already who's idle already. I don't want to see that, folks. I want to see everybody who is logged in actually in the activity that they're supposed to be in. Again, everybody should be in Canvas. They should be in the unit on analytical techniques. And again, just a reminder that I do attendance by looking at GoGuardian to see who's logged in and who actually is where they should be. Because if you're where you should be, then you're here. All right, good morning, Anthony. We are in Canvas and we are looking at analytical techniques while I do attendance. All right, so again, read that paragraph and go through the interactive review, and I'll come back and go through that with you as well. Let's see, somebody. Okay. All right. Curtis is, I have you logged in, but not on, it's not picking you up on GoGuardian. It's almost marked you absent. Okay, there we go. All right. Okay. So again, hopefully you read over the paragraph. And again, we are looking at um, this little bit of chemistry this next couple of lessons. So we are looking at, again, the fact that all living things are considered organic matter. So whatever state of matter they're in, solid, liquid, and gas, if it isn't a living thing, then it is considered the study of organic chemistry. And we have some tools and techniques that right up here, there we go, that we're going to look at in a little while, that we use to analyze the materials that we bring in from a crime scene. Okay. All right. So a little bit of a refresher course in biology or chemistry. Did everybody take chemistry? Is- Um, have you taken chemistry yet? Yes, no? I do. Okay. I see some thumbs up, some. Okay. You're a senior and no. Oh, I thought chemistry was required. Or you just have to. No, they changed the requirements so much. I thought you had to do biology and chemistry and then one other science. You don't have to do that? No. Georgia's changed so much. Okay. All right. And then for the seniors, I hope you read the message on um, the message board that you have to opt in or opt out, or whether you're going to attend graduation with at your home school or at LVA, or what you intend to do. So you have to make some decisions. So there's a lot of decision making that's due by Friday. So make sure that you're looking at all the message boards to see what applies to you and what doesn't. All right. Well, with that understanding that most of you have not had chemistry, then that changes things a little bit. So, and that's also good to know. So we kind of have to tweak this a little bit. So again, we're going to look at the fact that, and then you might have had, if y'all had physical science when you were in um, middle school. So you had a little bit of talk about the states of matter. So you know what solids, liquids, and gases, and that the molecules in a solid are very closely packed together. And when they're heated, they spread out a little bit and um, they become a solid liquid. So when things are melting, so the molecules are just spread out. They're still vibrating and moving around, but they're moving so much faster that they're not in a uniform state anymore. And then we have a gas is when you heat the liquid up a little bit more and the molecules move, get a lot of energy, and then they don't want to stay in the container anymore and they want to be all over the place. So gases have high energy. So all of these states of matter depend on the energy of the molecules. Molecules are always moving and they're moving very fast in a gas, kind of slow in a liquid, and very, 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 very slow. Like you're looking at the table that you're writing on or the chair that you're sitting on, and you're thinking that it's a solid, but the molecules in that chair or the table are moving very, very slowly. When things don't move, that's the temperature we call absolute zero. Mm, things don't move, they don't exist at that temperature. It's extreme temperatures. But right now, in our heads, matter is always moving. All right, chemistry. Chemistry is the study of matter. And like I said, the two types of chemistry are inorganic and organic. And when you're looking at your periodic table and you have 103 elements, a lot of them don't exist in living things. So we know which things exist in living things. So when we study organic chemistry, we're only looking at the molecules that are typically found in living things, such as carbon, hydrogen, oxygen, nitrogen, phosphorus, um, and a couple of other things, sulfur, those kinds of things. So there's a limited number of chemical substances that are actually found in organic matter. Okay. A basic atomic structure. When we talk, you do biology, you're talking about the cell is the basic unit of living thing. Well, the atom is the basic unit of everything. And atoms, the atomic structure is where you have where you had like the cell, you had a nucleus in the middle, you still have a nucleus in the middle of an atom. And inside the nucleus, you have protons and neutrons, which are positive and neutral particles. And in orbiting the outside of an atom, you have electrons, and they are negatively charged. Okay, so we don't need to know, atomic structure that much, but you do need to understand that at the base of everything are atoms and how they function. So when they send things through these machines to study, they need to know the behavior of the atom. And again, we're only looking at the atoms of organic materials, but still we need to know where it's located on the periodic table. Again, if you haven't had chemistry, I don't know how much you've gone into the periodic table where each column is a family and the members of each column behave a certain way. So they have that background to know what they expect of this atom to do. All right, pH scale. So we're going to talk about pH a lot because one of the tests that you need to do is to know whether something is an acidic substance or and this one says alkaline, but the other word for that is base, so acids and bases. Things in the middle of this scale are neutral. Water is neutral. Okay, so we take this and this one goes into the negative where it's really, really acidic. So it usually goes from 0 to 14, but this particular one that you're looking at has negative values to it. But if you look at the words, and let me bring this up a little bit bigger, zoom it out. I guess that's as best much zoom as I'm going to get. Okay, so you look at the words underneath, you see some things that might be familiar to you. So on the pH scale, things that are very acidic are hydrochloric acid. That's the acid in your stomach. So that is so acidic that if you don't put food in there while it can burn holes in your stomach. So that's a very powerful acid. Battery acid in your car. They um, I don't know, these electric cars and things, this is going to change, but the acid that used to be in the battery in your car um, was very acidic. Gastric acid, again, you have acids that help you with digestion, so they're around the range of 2, and then you have vinegar, tomato juice, uh, coffee, and milk and urine. So all of those are on the acidic side, but then they're mildly acidic. So coffee, beer, urine, milk, they're mildly acidic. And then we get to pure water, distilled water. That is neutral. It is neither an acid or a base. And then we come on the other side, ocean water, because it's got a little salt in it, is slightly basic. And then hand soap is basic. Um, the material that you've heard the word lye, the material that they make soap with is basic. Ammonia is a strong. So as we go up here, now we have strong bases. So on either end of this scale, you have things that can harm the skin. So a strong acid can burn you, a strong base can burn you as well. Bleach and lye. Okay, so those, be familiar with the fact that there is a pH scale. And I'm going to come back out of this Zoom. Okay. Alrighty. So what I'm going to do with the next few minutes of class is just to show a short video. I had two, but we only have time for one. I think that's this one. Let me get through this commercial, I'm sure.
Your child needs
Of course.
these 3 key factors to get into an Ivy League or top 25 university. And it's not having a good GPA or SAT score. Let me explain. 90% of students
skip you. All right, so we're looking at
The
analytical.
counterpart of traditional analytical chemistry
We're looking at
is
analytical.
modern analytical chemistry. The development of modern analytical chemistry has led to the advances of instrumental analysis. Under instrumental analysis, analytical tools and concepts such as spectroscopy, mass spectrometry, crystallography, electrochemical analysis, thermal analysis, separation techniques, and hybrid techniques fall under. One of the most useful tools in instrumental analysis, which you may encounter in your med school, is spectroscopy. Basically, spectroscopy measures the interaction of molecules with electromagnetic radiation or light. The amount of light that interacts or is absorbed by your analyte in a solution corresponds to the concentration of your analyte. Perhaps a better analogy is when you prepare a juice and illuminate it with flashlight. If the juice is diluted, more light is transmitted and less light is absorbed. When the juice is highly concentrated, less light is transmitted and more light is absorbed. Spectroscopy makes use of the equipment called spectrophotometer. The representative diagram of a spectrophotometer is shown. We have a light source, a monochromator, cuvette, and detector. The light source provides the electromagnetic radiation. The monochromator, which comprises of an entrance slit, dispersing device, and an exit slit, narrows down light to a single wavelength which is specific for the analyte. Take note that light is composed of multiple wavelengths. When a light ray of single
I'm
wavelength
going to pause that. Again, depending on which type of other science you've had, you might have talked about wavelengths and radiation and the colors of the spectrum. So this is what he's talking about when you have a solution that you're looking at. how when they send the light through it, depending on the density of the solution, you should be able to get certain colors to pop out. If they present certain colors, then we know that it's a certain type of substance. I'm going to forward this a little bit to the next one. Again, we don't have a lot of time. And there. Okay, now start it there. So just know that what the machine is.
This measures the mass to charge ratio of molecules using electric and magnetic fields. What happens inside a mass spectrometer is that your sample molecule is heated to a very high temperature. This one. And is bombarded by electron beam. So here is your electron beam. This process breaks down the molecule into smaller fragments of itself, which is then accelerated through this quadrupole by an electromagnetic field. The fragmented ions are caught by the detector, and the mass to charge ratio is being recorded. There is a very
Okay, like I said, I'm going to try to skip it through.
characterization technique that determines.
Oops, I don't think it liked me doing that.
Another instrumental technique used in modern analytical chemistry is crystallography. This is a characterization technique that determines the chemical structure of materials at the atomic level by analyzing the diffraction patterns of electromagnetic radiation, typically X-rays, that are being diffracted by the analyte. Suppose you have a protein crystal subjected to X-ray crystallography. The protein crystal is bombarded by an X-ray beam. The X-ray beam is being diffracted and passes through the crevices of the protein crystal. The diffracted rays are detected through a film, which results to the following diffraction pattern. The diffraction pattern is calculated using a mathematical model called Fourier transform, which can eventually lead to the determination of the 3D protein structure. Electrochemical analysis is fairly similar to potentiometric analysis. The main difference is that electrochemical analysis, like cyclic voltammetry, uses high-performance machine that measures the interaction of the material with an electric field. Thermal analysis, on the other hand, is a fairly common instrumental technique in modern chemistry. Calorimetry and thermogravimetric analysis fall under this category. This tool basically measures the interaction of analyte with heat. Usually, the energy ratings of the food that we eat are also determined by calorimetry. For example, the information that carbohydrates have a lower kilocalorie measurement, whereas protein and fatty acid rich food are high in kilocalorie measurement, are results of experiments utilizing thermal analysis. It has more applications than this, but shall be outside the context of our class. Separation techniques, particularly chromatography and electrophoresis, are two of the most useful analytical techniques therein. The main idea behind these separation techniques is the difference in the interaction of your analyte to the stationary phase compared to the impurities or other interferences. In chromatography, we have the terms stationary phase and mobile phase. The most common example of chromatography is paper chromatography.
All right, I tell you what, I'm going to go ahead and stop it there.
The analyte mixed with the impurity.
Okay, I'm going to stop it there because we are close to the end of class and he's still got quite a bit to go. But basically, I just wanted you to see some of the machines that are involved in analytical chemistry. I did not publish this next one. So next time you come to class, we'll actually take each of these and go through them. So I just published the next one, but we'll look at this one next. So he just started to talk about chromatography, and we'll look at that with the next class. Okay. All righty. So if you have no questions for me, you all have a blessed rest of your day, and see you tomorrow. See you tomorrow. Yes.